Supportability analysis is in a sense the essence of the systems engineering process from a maintenance perspective. So this is critically important. We are limiting the in-class work to 4 selected figures. Remember that the key to Blanchard is the figures. We start with figure 5.1, which is the Pearson New International Edition Chapter 4, figure 1. Here we have the way in which the supportability analysis proceeds during the systems engineering process. First, the analysis works from top to bottom through the conceptual design and preliminary system design phases. And then it is worked out during the detailed design and development phase from bottom to top as support resources are identified. Secondly, figure 5.4, PNIE Chapter 4, figure 4. This shows that supportability analysis is the process that ensures that there is an effective maintenance and support infrastructure based on the original system requirements. It is based on the following tasks that are performed during the analysis: predicting reliability and maintainability based on calculation and industry standards for components. Finding the system's operational requirements based on available information standards. Determining the personnel requirement. Doing an RCM analysis to develop a maintenance plan for the system. Doing a life cycle cost analysis. Performing a maintenance task analysis to determine the task steps and content. This is done for all preventive tasks included in the maintenance plan plus all corrective tasks identified during the RCM analysis. This will also form the basis of artisan training. And FMICA analysis. Essentially, this will be part of the RCM process. A data requirements and information systems analysis. This includes all data used and generated by the system as well as all information systems needed to manage the system. A spares and repair parts analysis, including all inventory to be kept for support. Analysis of the test and support equipment need. A LoRa analysis identifying what support actions should be performed at which levels of the support structure. Organizational versus intermediate versus depot. An operator task analysis to determine the work content of the operator, all operating procedures, etc. to form the basis of operator training. Facility utility analysis to determine what facilities should be created and what utilities must be available for the support process. Transportation and distribution analysis to identify all transportation that needs to be provisioned, as well as what distribution needs to take place. Thirdly, figure 5.8, PNIE Chapter 4, figure 8. Here we have a subset of the supportability analysis tools. Because the text is fairly small, this is broken up in 2 parts over the next 2 slides. Lifecycle cost analysis. Determination of lifecycle costs, high cost contributors, cause and effect relationships, risk areas, areas for improvement. FMICA analysis. Identification of potential failures, failure modes, their effects, their frequency, their criticality. Fault tree analysis, the determination of ways in which failure can occur, its probability of occurrence. Maintenance task analysis, evaluation of maintenance functions and tasks to be performed, task times, task steps, personnel needed, resource requirements, for instance spares, tools, facilities. Reliability-centered maintenance analysis, evaluation of the preventive task to be done for the equipment. Uses the information from the FMICA as a basis. Level of repair analysis of LoRa. Determination of the levels in the support structure where every maintenance action will be performed. Decision factors include economic, technical, social, environmental and political considerations. Evaluation of design alternatives. Evaluation of alternative design configurations. Fourthly, Figure 5.10, P&I Chapter 4, Figure 10. The cost breakdown structure, CBS. All the costs involved in the development of the system, capital costs, support phase cost. This concludes the session on system engineering and supportability analysis. Next, we will investigate maintenance task analysis.